Hi, how's it going? Welcome to Code with Z. In today's video, we gotta see how you can actually write a code that will calculate x to the power of 10 for us. So for example, 2 to the power of 10, because this is what LeetCode number 50 is actually asking us to do. Here it says, implement this function which calculates x raised to the power of n, like so. Now we're given a bunch of examples, but we have them in the slides, so let's check them out there. As you can see, our x is 2 and our n is 10, and we gotta see what's the answer of 2 to the power of 10. And if we think about it, 2 to the power of 10 basically means that we have to multiply 2 by itself 10 times, like so. As you can see, here we're multiplying 2 by itself 10 times. And if we calculate this, meaning if we do this multiplication here, that's going to give us 1024, and that's going to be our answer. So now we know that when we say, for example, 2 to the power of 10, that means we have to multiply 2 by itself 10 times. And because we have to write a code that will solve this problem for us, understanding this concept is really important. But for example, if our n was 3 and we follow the same concept that we just discovered, we're going to say we got to have 3 multiplications, right? So let's have one multiplication. We're going to start from 1. We're going to say 1 multiplied by 2. So here we're using one of our multiplication, and that's why our n is now 2. It was 3. Because we've used one of the multiplications, our n became 2. Now we're going to have another one. As you can see, this is our second multiplication, and our n has decreased once more. Now our n is still not 0, so we're going to do one more multiplication. We're going to say, we're going to bring 4 and we're going to multiply by 2 again. And as you can see, we've used 3 multiplications that we're multiplying a number by 2, and that's going to give us 8, and this is going to be our answer, and now our n is 0. And we all know that 2 to the power of 3 is going to be 8, and this is why it's going to be equaling to 8, because we have 3 multiplications. But what will happen if our n is actually a large number like 1,000? If we follow the same concept, that's going to give us 1,000 multiplications, because we have to multiply our number 1,000 times. And that's not very efficient, is it? So we have to do something else. Instead of multiplying our number by 2 each time, we can multiply the number by itself. Now, what does this mean? Well, let me show you. In the first round, we're going to multiply 2 by 2, and we're going to halve our n. It went from 1,000 to 500. Now, don't worry, you're gonna see what I'm talking about in a second. As you can see, 2 multiplied by 2, that gave us 4, right? In the next round, instead of saying 4 multiplied by 2, we're gonna say we're gonna multiply 4 by itself. 4 multiplied by 4, that's gonna give us 16, and we're gonna have our n once more. As you can see, instead of saying, all right, we have 4, let's multiply 4 by 2, we're saying we're going to multiply this result by itself, and we're going to halve our n each time. And in the next round, we're going to say 16 multiplied by 16, and that's going to give us 256. And now our n is 125. And as you can see, our speed has increased dramatically, because if we actually follow the previous concept, we're going to have this. We're going to say 1 multiplied by 2, that's going to give us 2. Then we're going to say 2 multiplied by 2, that's going to give us 4. Then 4 multiplied by 2, that's going to give us 8. In 3 rounds, we're gonna be at 8, and our n is gonna be 997. That means we have to do another 997 calculations to get to the answer. But here, only in 3 rounds, we've actually reached 256, and our n is 125. This approach here is way faster. And believe it or not, this is our algorithm, but there's one tiny simple thing that you still need to know. And that's gonna be what will happen if our n is a negative number. If our n is a negative number, we're gonna have something like this. So we're gonna have our 2, but we're gonna say 1 over 2 multiplied by 1 over 2, and that's gonna give us 1 over 4. As you can see, we still have our multiplication, and we're still using the number that we have. As you can see, 2 and 2. But the only difference is that instead of saying 2, we're going to say 1 over 2. So instead of saying x, we're going to say 1 over x. So we can simply say when our n is negative, we're going to turn our x to 1 over x, like so. So now instead of 2, we have 1 over 2. And now we're going to treat our n as if it was positive, because we've already applied the effect of n being negative to our x here. And as you can see, we're going to have the same thing. We're going to be like x is 1 over 2, so we're going to say 1 over 2 multiplied by 1 over 2, that's going to give us 1 over 4. Like so. Now, let's code this in the simplest way possible. Alrighty, so the first thing that we're going to do is to take care of the problem of when n is negative. So we're going to say when n is negative, we have to say x is equal to 1 divided by x, just like we saw in the slides, and then we're going to treat n as if it was positive, like so. We're applying the effect of n being negative here, and then we're going to convert n into a positive number. And then as we saw, we're going to multiply our answer by itself, and we're going to halve our n on each round. And because this is going to be a recursive function, we're going to be implementing it like so. We're going to say my power should be called x multiplied by x. As you can see, we're multiplying the answer by itself, and we're going to say n divided by 2. We're halving our n, and we're going to return this. And because this is going to be a recursive function, we do need a base case. As you can see, on each round, we're going to be making our n smaller and smaller. And we're going to say if n is equal to 0. So we're going to keep on going until n becomes 0. When n becomes 0, we want to return 1. Why? Because any number raised to the power of 0 is gonna be 1. So this is gonna be our base case. But for example, if our n is 240, when we divide it by 2, that's gonna give us 120, and that's totally fine. But if our number is not an even number, for example, if it is 5 and we divide it by 2, that's gonna give us 2.5, right? And that's gonna give us decimals, and we don't want to deal with decimals, so we gotta take care of this edge case, right? We're gonna say if n mod 2 is equal to 0, basically if our number is an even number, for example, that 240 that we just saw, we want to have what we had, because this is gonna work for even numbers, right? But if that was not the case, meaning, for example, if we had the 5, we gotta do something about it. So we have to take care of the problem of when our n is not gonna be even. We're okay if it is 4, but we're not gonna be okay when it is 5, right? So can't we just say 5 minus 1, and that's gonna give us 4, right? And this is an even number. Even if we had, for example, I don't know, 75, right? This is gonna be an odd number. Minus 1, that's gonna give us an even number. So we can basically say this is the code that works for even numbers, right? So we're gonna copy paste this, and we're gonna say we're just gonna get one of the multiplications out of it, and we're gonna multiply by it, and that's gonna make our n become even. Now, what does this mean? If you remember, our n is basically telling us the number of multiplications that we need to have, right? And here we're saying if our n, for example, is 75, that means we need to do 75 multiplications, right? Even if our code is faster and we don't need to do 75 multiplications, this is telling us that we need to have the result of 75 multiplications. So we're gonna be like, all right, we know our code works for even number of multiplications remaining, right? So we're gonna say add one multiplication here, and that means 75 minus 1, and that's gonna make it 74, and this is gonna be an even number. Why? Because here we're gonna be like, all right, we're gonna add one of the multiplications here manually. So we're gonna subtract one multiplication that we have from the number of remaining multiplications that we should do, because we've added it here manually. And this is gonna take care of that problem. So now we're gonna be like, if our n is an even number, do this, else treat it as an even number and add another multiplications to it. Now, this is all of our code, but when we divide our n by 2, when n is not an even number, we're gonna get decimals, and we don't want decimals, so we're gonna get rid of decimals, and we're gonna say math.floor, and we're gonna wrap n divided by 2 with it, and that's gonna get rid of the decimals. Now, this is gonna be all of our code. Let's run it and see if we're gonna get accepted. Yep, as you can see, all 3 are passed. Now, let me submit it and see if we're gonna pass all of the test cases. Drum roll, please. Yep, as you can see, that's awesome, and our time complexity is gonna be log of n. Thanks for watching. Don't forget to like and subscribe, and keep on coding.